Hey everyone, in this video we're going to talk about how to find removable discontinuities of a rational function, also known as the holes. How do you find holes on the rational function? Okay, and it's actually quite simple. Let's get to it. First, let's talk about what a hole is in a rational function. What it means is this. Let's say that we have a vertical asymptote at 1, and a horizontal at 0, y equals 0, and our function looks like this. Now, a hole will occur when you're actually missing a piece of the graph. Let's say that you're missing something here. Let's say that you're missing a term there at 1, 2, 3. At x equals -3, there is a hole on the graph. This is what it will sort of look like if you're looking for a function. But what it means is that whatever function you're dealing with, it's missing that term at x equals -3. Okay, it doesn't exist. Whatever it is that you're solving for will function or will work except for that number. Okay, so it'll be a regular asymptote, it'll be a regular horizontal asymptote, it'll be a regular function, except that now it's missing a piece, right? It is considered a hole in the graph. So all of these terms exist except for -3, and then you continue plugging in more numbers for it to exist as well. So let's do a few examples in terms of how do you find them. This is how you find them graphically, how do you find them algebraically, and then we'll talk about the rules that get you there. So in this example, I have this function x squared plus 3x plus 2 over x squared plus 4x plus 3. Now, I'm going to convert this function over to factored form, where I find the factors of the numerator and the denominator. The reason why I want to do that is because I can notice that there are some like factors on both functions. The top and the bottom both have an x plus 1. So I can actually cancel that and simplify the function to simpler terms. I can simplify it to f of x equals x plus 2 over x plus 3. Now this x plus 1 that we removed, that we canceled, is where the hole is going to happen. This is why it's called a removable discontinuity, because we're removing a piece of the graph. This x plus 1 that we removed is what we're actually going to be using to solve for it. So whatever you remove, the x plus 1, we're going to set it equal to 0 and solve for x. When you move everything to the other side, you get x equals -1. And this is where the hole happens. The hole for this function happens at x equals -1. What does it look like on a graph? Here's a quick sketch. So our graph will have a horizontal asymptote of 1. If you want to use this as a time to review your horizontal asymptote rules, notice that the numerator is equal to the denominator. The vertical asymptote will happen at -3. You can review the rules of vertical asymptotes by setting the denominator equal to 0. And now I have a graph that looks like this. Let's change colors here so that it stands out a little better. We have one here, and we have a graph here. Now, because there's a hole at -1, what that means is that we're actually going to have a piece here in the graph that's going to be missing. So at -1, we're going to have a gap. Everything will exist in this function except for x equals -1. And the reason why it's called a removable discontinuity is because we removed the x plus 1 from the equation to get x equals -1. we removed it, we simplified the equation, and notice how it was a continuous graph. It's continuous, every point exists except for that hole, and it continues. Hence the name removable discontinuity, also known as a hole. So what do? We convert the function first to factored form. Notice how the denominator can be expressed in forms of its factors. Once you have it in form of its factors, you can realize that the numerator and the denominator both have an x minus 5. Because they both have an x minus 5, we're able to cancel it in the top and in the bottom. When you're canceling a term, right, it's another way of saying dividing a term. So x minus 5 divided by x minus 5 is the same thing as saying 1, right? So canceling the top and the bottom really means anything divided by itself is just 1. So we can say this. F of x equals 1 over x plus 1, right? Anything divided by itself is going to be 1. So when you cancel them, you're really just putting a 1 there at the top. Now, my rule is I set the denominator, or I set the thing that I canceled equal to 0. Set it equal to 0 and solve. When you move the 5 over, you have a hole at x equals 5. So the function will have a hole at x equals 5. And we can draw a quick sketch of that so you can see what that looks like. It means that at x equals 5, we're going to have a gap. 1, 2, 3, 4, 5. Let's see, our horizontal asymptote will be at 0, or y equals 0. You can watch a video to talk about the horizontal asymptotes. The vertical asymptote will be at -1. So the graph will look like this. With an actual hole at that piece. Because that's where we removed it, at x equals 5. All right, so let's recap these rules. What you want to do when you're talking about how to find the hole or removable discontinuity is first you're going to want to convert this to factored form. Write it in the form where we have factors in the numerators and the denominators. Once you find your factors, you can do that through Lopez approach, right? Once you find them, you want to find the common terms, if there are any. If there are any, those are the terms that you're going to want to cancel. And whatever you cancel, you set equal to 0. And you solve for x. And when you solve for x, you get the location of the hole. So, factored form, cancel whatever is common, set it equal to 0, and solve for x. All right, guys, I hope this helps. You guys have a great day, and as always, we'll calc you later.